Well, we're really getting someplace now. We're at the point where we're talking about blood pressure. And if you're a typical American, probably someone in your life needs to concern themselves with high blood pressure. So let's just talk a little bit about blood pressure. First of all, blood pressure is technically the force that blood is exerting against a vessel wall. It is how hard the blood inside is pushing against that vessel wall. And blood pressure is really only significant inside of your arteries. Um, it gets smaller and smaller as it goes down to the arterioles, but keep in mind that arterioles are pretty fragile things. So high blood pressure does its most damage down at the arterioles. We generally measure blood pressure right here at the brachial artery, and that's because we can do it without asking anyone to disrobe. It's not uncomfortable to measure someone there. It doesn't have to be measured there. You could measure someone's blood pressure on their leg, for example, but technically we don't usually do that unless someone's in the emergency room. I want you to know the difference between systolic blood pressure and diastolic blood pressure. Let me remind you of the word systole. Systole was spelled Systole. And systole, when you don't say a word in front of it, refers to contraction of the ventricles. So during systole, we're getting this big push of blood going out. And so during systole, blood pressure will go up because whoosh, we get this big push of blood. So systolic pressure is blood pressure during ventricular systole. Diastolic pressure is during ventricular diastole, right? And when the ventricles are completely, that was hard, man. And so they're relaxing in between heartbeats. There's no pressure inside of the ventricle. And so your blood pressure goes down a little bit. That is diastolic pressure. Normal blood pressure for a young person is going to be something like 120 over 75, maybe 110 over 60, something like that. I'm not going to ask you to memorize normal blood pressure, but a little bit later we are going to be asking you to memorize the boundary for high blood pressure. The difference between the 120 and the 75 is the pulse pressure, and blood pressure in general and pulse pressure are two important measures of how hard you are working those small arteries and arterioles. You got to be nice to them because if you put them under too much pressure, they just pop. So systolic pressure is always the first number in a blood pressure reading, and it's always the higher number. Diastolic pressure is always the second number, and it's always the lower number. Systolic and diastolic are the two numbers in a blood pressure. And we will usually say that someone's blood pressure is 120 over 75. That's usually how it's said. So if your aunt tells you that her blood pressure is 110, you have no idea what that means. It's either very good or really lousy. Needs two numbers. And the reason why it's got two numbers is because when the ventricle goes into systole, it sends out a surge of blood, and then as the ventricle regroups, the artery kind of snaps back, and then it goes back down, and then it goes up again, and then it goes down. And in all of your major arteries, it stays about the same. It starts going down in the arterioles. It really drops in the capillaries. And by the time it gets into the vena cava, look at how low pressure inside the vena cava is. It's only maybe about 5 millimeters of mercury. Systolic, diastolic, okay? There are three ways that your body regulates your blood pressure. It does it by regulating blood volume. That's number one. Regulating blood volume. Did you know that you don't always have the same number of cups of blood in your body? Changing that blood volume, this is a job that's mostly done by your kidneys. We're going to be talking about how your kidneys regulate blood volume when we get to the urinary system. Your body can also increase your blood pressure by constricting your blood vessels, particularly the small arteries, or relaxing, dilating your blood vessels. So if a blood vessel goes from here to there, that would be called constricting the blood vessel. If it goes from here to here, that is called dilating a blood vessel. If you take all of your blood that's like this and you force it to go into there, blood pressure is going to go way up. If your blood is all in here and you relax your blood pressures, your blood pressure will go down. If a patient's blood pressure is too high, we've got medications that will cause their blood vessels to do this, and that drops their blood pressure. A third way your body controls blood pressure is by controlling how hard and how fast your heart is beating. Actually, controlling your cardiac output. Remember, cardiac output is your stroke volume multiplied times your heart rate. It's the number of milliliters of blood that are getting kicked out by your heart in every minute. If cardiac output goes up, everything else being the same, if cardiac output goes up, then your blood pressure will go up. And all of the things being the same, if your cardiac output goes down, your blood pressure will go down. This is another way that we regulate people's blood pressure when they've got high blood pressure. Now, a lot of this happens because of hormones, and I've got a specific story for you later in this video. So blood volume, all of that, good. So now we know the three basic mechanisms that your body uses to control your blood pressure. And remember homeostasis, we want everything to stay in the sweet spot. We want your blood pressure to not too high, not be too low. It's got to be just right. But how does your body even know what your blood pressure is? Like if I ask you right now, what's your blood pressure? Do you know? Well, consciously you don't know, but your medulla oblongata does know. Why does it know? There are special mechanoreceptors in the heart. Oh, mechanoreceptor. Let me spell that for you. Let's spell mechanoreceptor. There are mechanoreceptors in the heart and right in the arteries right above the heart. And those mechanoreceptors that measure blood pressure are called baroreceptors. Okay? So the mechanoreceptors that are there in the large arteries right above the heart are known as baroreceptors, and they are found in three basic areas. They're found right in the aortic arch. And the aortic arch is that part of the aorta that kind of, well, it's an arch. They're in the aortic sinuses. The aortic sinuses is right where your coronary arteries branch off of your aorta. And then they're also here at the carotid sinuses. The carotid sinuses are way up here. So those mechanoreceptors, they are special stretch receptors. When blood pressure inside of your arteries is really high, then the arteries being stretched, and these mechanoreceptors are being stretched, and so they will send out very, very frequent action potentials. When your blood pressure is too low, then their artery's not stretched at all, and the mechanoreceptors aren't being stretched at all, and they don't send out action potentials at all. Let me show you what that is going to look like. So we've got some areas here, right here. We've got mechanoreceptors. Up here, we've got mechanoreceptors. And these mechanoreceptors that measure your blood pressure are called baroreceptors. And if this artery was being stretched a lot, then they would send a lot of action potentials kind of going, ow, 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 I'm being stretched too much. And that would tell your medulla oblongata, hey, my blood pressure is kind of high. And one of the things that your medulla oblongata would do would be to send out a signal down here to your sinoatrial node and said, you know, maybe we should make our heart beat more slowly. And if your heart beat more slowly, that would decrease your cardiac output. And if we decrease your cardiac output, then that would decrease your blood pressure and things go back into the normal zone, right? The opposite thing might also happen. It might also be that these baroreceptors are not being stretched enough. And if your baroreceptors are not being stretched enough, then they would go silent. And when the medulla oblongata is like, wait a minute, I'm used to hearing a beep, 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 and now instead I'm hearing nothing. Uh-oh, our blood pressure's not good enough. So your medulla oblongata would say, okay, let's tell the heart to start beating harder and faster. And if we say the heart should start beating harder and faster, now your heart rate goes up, your cardiac output goes up, so that would raise your blood pressure, okay? So the medulla oblongata does know what your blood pressure is and is constantly adjusting how hard and how fast your heart is beating in order to keep it in the sweet spot. When we exercise, more of our capillaries in our skeletal muscle open up. So that by itself would drop our blood pressure. But why does our blood pressure not drop? Because when our blood pressure starts to go down, the medulla oblongata gets the message and said, hey, I better make my heart beat faster to supply all that extra blood that the skeletal muscle needs. And we keep our blood pressure under control because our heart beats faster when we exercise. Who knew? So this is the kind of signaling that's coming from those baroreceptors, that special kind of mechanoreceptor. They're in the carotid arteries, the aorta, two places. If it's normal, then this is what's going on. It's like a beep, 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 and the medulla oblongata is just listening to the beep, 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 and your medulla oblongata goes, oh, everything's cool. If there's blood pressure gets low, then your medulla oblongata goes, oh, I'm not hearing any beeps. Oh no, blood pressure too low. Sends out something to make your heart beat harder and faster, brings it back up into the normal zone. If your blood pressure is like beep, 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 that's the medulla oblongata goes, oh man, I do not know what's going on, but that's too fast. I'm going to tell my heart to slow down and cool out. Sympathetic stimulation or sympathetic tone will make your heart beat harder and faster. Parasympathetic tone would make your heart beat more slowly. So baroreceptors, they measure your blood pressure with special mechanoreceptors that fire off action potential as they are stretched. There are other sensory receptor cells in these same general areas, okay? Here are where we've got the baroreceptors in the carotid artery. Right near there are other sensory receptor cells that are like tasting your blood. They are chemoreceptors. Those chemoreceptor cells are tasting your blood kind of for how acid your blood is. And those chemoreceptor cells, they can change your heart rate, but we're going to be mostly talking about them when we get to the respiratory system, which is going to be our next topic. So keep them in mind. The chemoreceptor and mechanoreceptor cells are in the same vicinity, but in slightly different areas. So with that, we're going to do one last video. I hope it's the last one, and I'll see you then.